Hello everyone, in this video we present Pedestrian Graph Plus, a fast pedestrian crossing prediction model based on graph convolutional networks. In recent years, models specialized in the pedestrian crossing prediction task have increased their accuracy. However, their computational cost has also increased. These models must meet two fundamental requirements. They must be accurate and perform real-time inference. Graph convolutional networks combined with human pose estimation data demonstrated high accuracy in action recognition, outperforming recurrent neural networks. The use of human pose data is ideal in the pedestrian crossing prediction task due to its low computational cost and real-time inference. However, human pose estimation lacks environmental information. In this work we propose a novel architecture, an efficient and multimodal architecture based on graph convolutional networks. Our model integrates two parallel modules to the Graph Convolutional Network, fusing human pose data with cropped images, semantic segmentation maps and vehicle velocity. This adds context information and increases accuracy while preserving low inference time. In addition, Pedestrian Graph Plus has the ability to vary its input size dynamically and with virtually no loss of accuracy compared to other models. This is useful when the tracking algorithm has a limited number of samples. This is usual when a pedestrian is detected for the first time. We also develop two techniques that increase the accuracy of the model without affecting its inference time. The first is the use of human pose forecasting, which predicts the next 30 frames. The second technique is the use of three labels: crossing, non-crossing and irrelevant, which are then mapped. Pedestrian Graph Plus achieves performance comparable to other state-of-the-art models, but with much lower computational cost and inference time in comparison. Pedestrian Graph Plus takes a series of 32 frames of 19 human keypoints in 3 dimensions as input data. The last frame of the sequence together with the segmentation map is trimmed with the bounding box to form a 4-channel image. The GPS and OBD speed data are concatenated into 2 channels. In training, the sequences are randomly trimmed to preserve accuracy in short sequences. In our architecture, the main module is a GCN, which, apart from processing human keypoints, receives data from parallel modules. These modules provide the visual information and the ego vehicle velocity. This is done by 1D and 2D convolution and a global average pooling (GAP) module. In this way the channels of the GCN feature maps are weighted. This procedure is inspired by the squeeze and excitation networks model. Our experiments show that the addition of visual and velocity data increases the accuracy of the model. We can also observe that Pedestrian Graph Plus virtually does not lose accuracy in short sequences. All experiments and results are reported with the JOT and PI datasets. Pedestrian Graph Plus obtains similar results to state-of-the-art models. Now we see qualitative results from Pedestrian Graph Plus. Incorrect predictions are highlighted in red and correct predictions are in green. We can also observe the 3D human keypoints. We also tested our model in other videos, which are not part of JOT and PI. We can observe that Pedestrian Graph Plus has good generalization on samples that were not seen. Thank you for your attention.